Hey guys, so my name is Matt, I'm a tutor, and we're going to go over a stoichiometry review. We're going to figure out what this massive number is. We're going to figure out what a mole is. We're going to figure out how to use this big triangle thing, and with the help of a periodic table, how to do every single question that your teacher can throw at you. So first, what is a mole? Well, 1 mole is just equal to 6.022 times 10 to the 23 things, right? So of course you can have a mole of hydrogen gas, but you can also have like 1 mole of pennies. A mole of pennies stacked is actually longer than 6 times the length of the galaxy. 1 mole of carbon is actually just equal to 12 grams. So that shows how small atoms really are. But why? Why is 1 mole of carbon just 12 grams? Well, for that, we're going to need the periodic table. So here we have our periodic table, and we're going to zoom into this example of sodium. Here, you can see the atomic number is 11. The atomic number is just equal to the number of protons in the nucleus. The atomic weight, or the mass number, this is equal to the number of protons plus the number of neutrons. So as you can see, 11 protons with an atomic mass number of almost 23 means that there are 11 protons and 12 neutrons in sodium. And so now let's slide over the periodic table and head to carbon. Carbon is my favorite element. Carbon has an atomic mass of 12. So he asked himself, how many carbon atoms does it take to weigh 12 grams? And what he found was that it took 6.022 times 10 to the 23 atoms of carbon to weigh that 12 grams. And so he said, well, this is what 1 mole is. 1 mole is 6.022 times 10 to the 23 atoms. And he continued his experiment, and he said, okay, let's forget about carbon. How many atoms of oxygen does it take to weigh its atomic mass in grams? And its atomic mass here is 16. So how many oxygen atoms does it take to weigh 16 grams? And what he found was it was 6.022 times 10 to the 23 atoms. He also knew that oxygen was not in its atomic form in the environment. Oxygen in the environment is actually O2 molecules, right? And so what is the atomic mass of O2? Well, we have 2 oxygen, so it's going to be 2 times the 16. So how many O2 molecules does it take to weigh 32 grams? And he found, of course, 6.022 times 10 to the 23 molecules. So now let's do some review. 6.022 times 10 to the 23 things is equal to 1 mole. So if I were to ask you, how many molecules are in 3 moles of H2? Well, what would you do? Well, I'm looking for the number of molecules, and I know this is equal to 6.022 times 10 to the 23 molecules per mole, and I know I have 3 moles, so if I multiply that by 3, I will get the answer. And it turns out it's 18.066 times 10 to the 23 molecules. So what is this formula? Well, the number of molecules, or number of things, equals Avogadro's number times the number of moles, and number of moles is n. What if instead of how many molecules in 3 moles of H2, I asked you how much does 3 moles of H2 weigh? How much does 3 moles of H2 weigh in grams? Well, I know that 1 mole of H2 equals the mass of its atomic mass in grams. And so if I spawn my periodic table again and I zoom in, the atomic mass of hydrogen is 1. So this means that 1 mole of H equals 1 gram. Well, I'm working with H2, right? So that means 1 mole of H2 is going to be double that. It's going to be 2 grams. So now I can see here, this is going to be 2 grams. Well, I have 3 moles of H2, right? So therefore, 3 moles of H2 equals 3 times 2 grams, which equals 6 grams. So what equation am I using? Well, the mass is equal to the number of moles, which is N, times the molar mass, which is the mass of 1 mole, which is capital M. And this is the equation we'll use. So let's do a harder question. How many moles are in 204 grams of MgOH2? Well, we know that mass equals the number of moles times the molar mass, right? But now we're trying to find moles, so let's get this by itself by bringing the molar mass to the other side. And the way we do that is by dividing by molar mass here, cancel these out, and dividing by molar mass on the other side. And what we get is mass over molar mass equals the number of moles. So I can rewrite this as the number of moles equals the mass divided by the molar mass. So the number of moles equals 204 grams divided by, what is the molar mass of MgOH2? Well, we have to go back to our periodic table, but it's going to be the molar mass of Mg plus 2 times the molar mass of oxygen and 2 times the molar mass of hydrogen. So 2 times the molar mass of oxygen plus 2 times the molar mass of hydrogen. And now let's finally get our periodic table out. So we have our periodic table down here. The molar mass of magnesium, if we zoom in, is 24.3. The molar mass of hydrogen is 1. And the molar mass of oxygen is 16. So the molar mass of magnesium, remember, 24.3 plus 2 times the molar mass of oxygen, which was 16, plus 2 times the molar mass of hydrogen, which is 1. And now if we do the math, it's 204 grams divided by 24.3 plus 2 times 16 is 32, plus 2 times 1 is 2. And remember, the units of this are in grams per mole, because it's how many grams are in 1 mole. So if we do the math, this is 204 grams divided by 58.3 grams per mole. And now 204 divided by 58.3 is equal to 3.5 moles. Because remember, these grams cancel out, and we're dividing by division by moles, so it's going to be 3.5 moles. Does that make sense? If you have any other questions about stoichiometry, any other questions about chemistry, physics, biology, mathematics, I can help. I will make a video for you guys. All I ask is that you guys like and subscribe, and yeah, thank you.